that's me. I've worked at Stack Overflow for about 5 years. This picture is of our error page, a page I hope none of you have ever seen. We actually cycle through all the developers on it, but please, don't go there on purpose. What I'm going to talk about are our numbers, a bit about how we do stuff at Stack Overflow. That means the teamwork. I'm going to talk a bit about our web platform, the tools we use, how we think about and deal with scaling and performance issues, and a little bit about our cloud strategy. I will let most of the numbers here to speak for themselves. I will only mention a few things when I think that would be of more interest than just the numbers here. So these numbers are just for everything in the network. On occasion, it's just for Stack Overflow. That will be on the slide when it's just for Stack Overflow. Here we go. A lot of caching. Thank you, Salvatore. Tag Engine is a unique beast. It is an in-house tool. It's essentially a specialized database. As you all know, when you ask a question on Stack Overflow, you put tags on it. On Stack Overflow, on our other 170 sites. And the Tag Engine is a way to query and find out what tags are on what question. So this is an in-house tool. I'll talk a little more about it later. So all of these big numbers run on actual hardware. And we'll go and see how much hardware needs in order to run a site like Stack Overflow. One live SQL server runs Stack Overflow. Second one is just a read-only replica. We do use it for data that doesn't change much, when we just want to query, when we don't need to write. We use that as well. That's the rest of the network. That's another 170 Q&A sites. And you'll notice it has about half the RAM that the Stack Overflow one has. Yep, only 9 servers. That's it. 2 Redis servers, we don't need more than that. The performance is awesome. Yeah. The Tag Engine servers run on boxes that do other things. They don't require so much performance. Things like schedulers, things like that. So this is hardly any hardware. There's maybe about 30 of these boxes altogether. It's just one whole rack in a data center, if that. Yes, we have another set which is for disaster recovery in a completely different data center, but that one is just for disaster recovery. It doesn't deal with production at all. So little hardware. So many big numbers. Now's the time for some smaller numbers. All of that, 18.3 milliseconds for server-side renders of the question page. 12.2 milliseconds to render the home page. So how do we do this? I'll start with teamwork, because people is the most important part of any organization. We're everywhere. We're around the world. Unfortunately, no one in Italy at the moment, but that could change. So we are a distributed company. We started distributed. When Stack Overflow started, the developers, management were on pretty much two different sides of the states. So everything started that way. And we are continuing, Stack is continuing that way. Right now, around 250 people. The way we structure the teams is multidisciplinary. So that means people from marketing, programmers, management, designers, product manager, they're all together, they're doing one thing. We have a lot of different teams, but they're fairly small, 5 to 10 people, and different areas. When we communicate online, when we need to talk to people face-to-face, we use either chat or Slack. That depends on the team. Salespeople tend to like Slack more. The technical people tend to like the Stack chat more. Has anyone here ever used the chat, the Stack Overflow chat? Didn't even know it exists. It's there. You can create your own rooms. You can chat to other people. It's a nice little platform. Outside of that, team meetings, or if we need to talk to each other, we go into Hangouts. Sometimes for really large things, for whole company stuff, Zoom will be used, simply because it supports more people in one room than Hangouts can. A lot of little things are recorded and uploaded to YouTube. The point here is to have artifacts that anyone can see at any time. If someone can't make a meeting, there's a recording. If not a recording, it's written down, somewhere that everyone knows where it is and can access. These are things that you have to have in order to work effectively in a distributed group. So async stuff, like I was saying, Google Docs, Trello for project work and organizing. Some developers just have their own Trello boards for their own specific project when they're working on it. Sometimes they share it, so people will know how things are going. YouTube, again, like I was saying, stuff is recorded and uploaded, so we know what's happening. Our chat and also Slack, to an extent, has some chat bots. So here you can see when a CI build is running, when it was triggered, after someone pushed something in, we know exactly what they've pushed. And the same thing when someone goes and puts something into production, we know exactly who it was and when. This is valuable information during your workday to see what's happening, to know if your changes have gone live or not. If you have to wait before you push because someone is just deploying everything to production, you don't want to mess that up. Exception, if there's a lot of exceptions, we want to know about it immediately so that they come up in the chat room. Sometimes we see highly unusual exception levels and specific exceptions, sometimes more. And we use them for a lot of fun. So you can see right there, Nick Craver is saying high five, and one of our bots is giving a high five there. We also have, Samu here posted this. Who cares? Does anybody care about beer cans? And the honey badger says that he really does not care about anything. Again, another, just a bit of fun, because it helps break up the day. And we have other things. We have our picture bot. Based on that picture, someone, Haney there says, needs more managers, and we have a couple of managers showing up on the picture. Outside of that, we have the wheel of blame. The wheel of blame basically goes and chooses someone in the room to say it's your fault. Now let's see if we can see a video of that. Hopefully the audio will work for it. Oh, sorry about that. Can you all hear that? Nothing. There's a music happening in the background. I don't know. It's saying, who is it? Who's it going to be? Who's going to choose me? Ooh, just passed me. Oof. Wasn't me. And Oh, Abby's fault. It's her fault for the rest of eternity. So, I think the next slide will come as a bit of a surprise to a lot of you, because we run on C# and SQL Server, mostly. Again, the rest of it, again, ASP.NET MVC, IIS, yes, it's a Microsoft stack at its core. But not only. HAProxy, Redis, Elasticsearch, they run on CentOS, and Tag Engine does run on Windows right now. Why? Because it makes sense to run these things on those platforms. We are not going to run Redis on Windows. No. We are not going to run SQL Server on Linux yet. It is something that exists now, and we're evaluating. Tag Engine, we might move to .NET Core, and at that point, maybe it makes sense to run on Linux, maybe not. It's the kind of thing that would be tested and tested and tested until, if we see that it makes sense, we'll do that. These are our main tools that we use. Again, Visual Studio, obviously. Anyone who uses C#, .NET would be using that. We used to use GitLab. It's actually now GitHub Enterprise for various reasons. I did not update this slide. Sorry about that. How do we do stuff? All developers have a local environment. It's not a full Stack Overflow database. That is just a bit too big. A few terabytes uncompressed. So downloading that over even a fairly large broadband connection, no. So we will use some other database, another Q&A database that's large enough to give us a good idea of how things are, and that has enough good data to work off. And again, it will have everything. One of the best things about being a developer who starts at Stack is this thing, dev local setup. Set of scripts, you run that, it will download everything you need. You need SQL Server, it'll download and install that. It'll download and install databases, code, everything. Make sure your Elasticsearch isn't there. It'll get it for you. We have it set up for many different teams, Q&A, careers, etc. We usually just work directly off master for most of the work we need. Just push it, and it'll go to production fairly soon. If it's something complex, or we're touching something that is sensitive or really complicated, we will create a branch and ask for a merge request on it. So examples of that is if we change the layout page of the site. That is every single page on Stack Overflow. And we don't want necessarily someone to have a alert false come up on the site, which has happened in the past. The Q&A codebase itself does not have many tests of any sort, no automated tests. Other teams do things differently. Our careers team definitely has more tests. They also deal with people's money, and they need it. They need more rigor. We have, on Q&A, we have our community that will tell us very quickly if something is broken, through our meta sites, which I'll come to a little bit later again. A developer on his first day, once he's set up, if he has a fix, he can push to production on that day. It takes us 10 minutes from pushing the code out to GitHub till it can be on prod. Now, because we have this very fast cadence, it means that we can, instead of rolling back, we can roll forward sometimes. What does that mean? Fix it and push it quickly before anyone notices. So meta sites. We have two, every Q&A site has a sub-site, which is a meta site, where we talk about the site, how it works, report bugs, request features. This is a community thing, of course, not so anyone can do that. Log on to Stack Overflow. There is a meta Stack Overflow, and we also have a meta Stack Exchange, which is kind of a meta for everything in the network. If there are bugs there, for things that affect all the sites or features that you think are good for all of the sites, they will usually be on Meta Stack Exchange. This is important because those two sites are the first two sites to get the code. They are our staging environment. So at that point, it's actually production. But only on two sites. People who use them will usually notice if something is very wrong and will let us know very quickly. Of course, we also monitor that. Once we do these builds, either a meta build or prod build, which pushes to the rest of the network, including Stack Overflow. It's the same code base, by the way, for all Q&A sites. It's one web application. So once that happens, we will watch the logs. We'll keep an eye on Meta, see if anyone is complaining, if there are any issues, especially with the stuff that we've seen. Keep an eye on the exception log, etc. So we push. What does the build server do? Does a lot of compilation, localization. How many of you know that we have a Stack Overflow in Spanish? One in Portuguese, Russian, Japanese. So all of this is done during build. It pulls the data out of a database and actually compiles it into the executables, both JavaScript, C#, etc. Again, the SQL migrations that we have, it's an in-house tool. Again, it's a fairly old code base by now, about 8 years, 9 years now. So we have all these tools that we created internally that, okay, now there are actual solutions out there that are quite good, but this predates them, and we're not going to change something just to change it. Okay, talk a bit about performance and how we actually reach such small numbers with so little hardware. So it's one of the things we have on each and every page load as a developer. We get this little tab, which is our mini profiler. Again, this is a tool that was written in-house, comes up in the browser, and it gives all kinds of warnings. So if I click on one of those tabs, you can see I will get all kinds of information about SQL, Redis, how long it took. In this case, it tells me you've had 2 of these exact query happening there. This shouldn't be happening. It's a warning. It's an extensible framework, so I think someone's working on adding Elastic to it, Elastic timings where relevant. And it gives us a very good idea of where rendering time, server time, is being spent. For developers, because we have a lot of additional stuff on the page, it's not quite as representative as a normal user. But drilling down deeper into Mini Profiler, I can actually see the SQL queries that were put with whatever parameters, essential for debugging stuff. I can copy this, paste it into SSMS, run it against my local, run it against a read-only replica, maybe production if I'm really stumped, to figure out where the time went. This also includes, you'll see Redis times, how long that took to fetch that particular key. And again, more of the same. Another thing we have is this dashboard, Observer, again written in-house by one of our members, Nick Craver. It's not just a dashboard, it also allows us to actually control things, take servers out of rotation, turn things on and off. This is essential to see what's going on. So you can see things like how much memory is being currently used by a server, whether it's web or SQL. Here are the web servers themselves. You can see that they're running at a very small percentage here. This is intentional. Again, it's to give us room to grow. If something happens to a server, it's really not a problem. And here are the SQL servers I mentioned before. So I think you'll see here that our, where's the, no, sorry, I can't see how the memory and how much memory they have, but anyway, we have 1.5 gigabytes for Stack Overflow and half of that for the rest of the network, which I think I mentioned already. If we go into one of them, you can see more detail, exact CPU graphs, timing, again, essential stuff if you want to be able to do your performance. You drill down into the top queries on SQL Server, look at exceptions, exception details, how many have been thrown in a period of time, which ones, by whom, with a breakdown by specific areas. So I can go specific sites, I want to look what's happening in chat, or mobile site, our Q&A, which is here called core, etc. Some more details about Redis and the different hosts, the roles, etc. And similar for Elastic. And HA proxy. Here, what you will see is where we can say, just don't send any more traffic to that particular server for this specific application, because maybe something happened to it there, and we just want, to load balance to the other servers instead. If you haven't used Grafana, it's an awesome dashboard. Great graphs, great visibility into what's going on. Another tool we use is called Boson. This is kind of our alerting tool, used mostly by our SRE team. What you see here is a query. It runs off OpenTSDB, time series database, and queries that in order to generate all the information it has in the queries. The idea here is that you can write a query to make an alert, to base an alert on. So it's programmatically done. One of the things that you'll see here, it's email templates, what needs to be in them, what details, links back into Boson, whatever you need, breakdowns by server, and etc. One of the things that I have not seen any other tool do is that you can write your query and test it against past data. So you can actually see, is it alerting on the right things? Is it not alerting on the things it shouldn't do? So, you reduce your amount of false positives and false negatives by having a tool that can actually look back and run the query and tell you, and you can basically say, yes, it did exactly what I wanted it to do in that situation. Very valuable. Mini-Profile, Observer, and Boson are Stack Overflow created and shared. They're all open source. Mini-Profiler is not just a .NET thing. You can run it on Ruby and other platforms. If you want to go to Stack Overflow, see all our other OSS stuff, we do have more than this. Examples are Dapper, our micro-RM, and Jill, which is JSON serializer, deserializer. This happened. A bad deploy killed 8 of the servers, only 1 was live. We noticed, we felt it, none of you did. That's how much headroom we have. And that's one of the reasons we have that kind of headroom. Now, all this monitoring that I mentioned might sound boring, but if you can't measure something, you can't optimize it. You don't know where to go. You don't know what's the worst problem. You fix an issue, fine. Maybe it caused a problem. Maybe it didn't, but you need to know. And all of these tools give us this kind of information. So when it comes to optimizing SQL, everyone goes through a course, a very deep-level course about optimization. Everyone in the team learns how to do this, how to optimize by query plan, etc. And again, we have Mini Profiler to help us with that. So we do a lot of caching. You saw in an earlier slide that 99.9% of static requests hit our CDN. So tiny amount of that. And other caches. So L1 cache is what we just call the memory on a specific server. And L2 is Redis, which basically goes, web server kind of goes, I need this piece from cache. Do you have it? If it's in its memory, it just retrieves it. If it's not in its memory, it asks Redis, gets it from Redis into its memory, and can use that. If it's not in Redis, then it needs to do whatever work it does need to do in order to populate Redis, and then the next tiers. It really depends what we do. An example for that is the footer is dynamic, but it doesn't change that often, so we cache it in Redis for all the web servers for a week. So the caches have all kinds of things, mostly results from database. Mostly we'll have things like lists of integers, of IDs of questions, IDs of answers, or IDs of questions and answers together. These are small things that are easily cached, and then we can just go to the web server and say, give me these IDs, which is super fast if you have an index on that table. I've mentioned these two libraries. Again, these are things that were written in-house. They are open source at the same time. We use these because the tools that existed, Link to SQL, were just too slow for a lot of the work. So we still have a tiny amount of Link to SQL, mostly because of very complicated dependencies between objects, but as little of it as possible, because it is really, relatively speaking, slow. And again, the same goes for the JavaScript serializer and other serializers. We have been approached by some teams saying, we have a serializer that will do this and that, and it's a cost-benefit analysis here. Sometimes they are faster, but the results they give are worse. Sometimes people have asked us for something that is more accurate, and we can say, yeah, you know something, you're right, it is more accurate, but it's 3 times slower for our workload, so we're not going to use that. Did I mention that? So the philosophy here is the performance is a feature. This is something that everyone on the team is really passionate about. It's important. You see something slow, you go and dig into it. You figure out why that happens. It's understanding when you need to offload work. I mean, the tag engine. Instead of doing it in SQL Server and working that very expensive resource, let's farm it up to something else. We could use full text search in SQL, but why do that when you have Elastic? So again, all these things come into it. Understanding the architecture, understanding what's expensive, and where you can offload work. Okay. The cloud. Has anyone seen anything about that yet in this presentation? We don't use it, really, in our architecture. Why? We did a cost-benefit analysis. We found out that for us, it'll cost more. Partially because, we don't need all that much hardware. And again, this is direct cost savings. Performance work matters. And again, it's not fit for requirements, which the requirements being very high performance and tight control of it, which means that when you have in data warehouse between nodes on the cloud, you have a lot of jitter. A request can take 10 milliseconds, but it can also take 100 milliseconds or half a second. That's not acceptable. It's not in my control, so I don't want it. Again, this isn't something that is true for everyone. And again, we do have our own hardware. If you don't have your own hardware, it's something you need to kind of think about. Another little thing that we would need to do, at least with Azure not being able to offer us a large enough capacity for a database, never mind that the SQL option that they have lacks a lot of features that SQL Server has. So again, I wouldn't want to start restructuring a database like that. And again, the capacity is supposedly there, but it's not immediate. It doesn't respond in real time. It actually takes a bit of time to go, oh, yes, I've dropped 100,000 requests. Maybe I need more CPU or more whatever it is. So, and again, I was talking about the jittery internal networks, and there's a matter of latency as well. We do use it a bit, but mostly for backups and DNS. We actually use that for DNS because we are also optimizing our DNS query time. That's it. Thank you. Questions, please.
Hi. During spikes, how much CPU do you use? During spikes, how spikes in your traffic? How much CPU do you use?
We're not very spiky.
Okay, so
it's just not. I mean, cloud makes a lot of sense when you have spiky traffic, when things change. I mean, things like sports sites where, a sport event will happen and suddenly, millions of people jump in. It just doesn't happen at Stack Overflow. You can see a very steady amount of traffic happening. We don't get suddenly millions of people coming into a site to figure out what's going on.
traffic doesn't change during the US daylight time?
Because it's a global community, you don't see a lot of that. We see a drop on Stack Overflow during the weekend, definitely. But it gets offset by sometimes other sites. Because we have a gaming site, computer gaming site. And that one shows the exact opposite profile for obvious reasons. Any other questions?
Yeah. Well, cool for your talk.
Let's wait for the clapping to die down.
Great, cool talk. My compliment.
Yeah, at your company.
Yeah. No, my compliment to you for your talk.
Thank
you. Okay. My question is, how do you generate cache? Is that at offline process? Is that a batch process to generate cache fragments or cache data?
So you're asking, let's see if I understand you correctly, when do we clear out a cache? How we decide to do that?
Yeah, exactly.
Our caches are basically time-based, most of them.
Okay. Sorry, this is for cache invalidation. My question is, how do you generate cache? Do you do cold cache start? That is one request arrive. Okay, so let us memorize this cache fragment, or you can generate that cache fragment in a batch process.
What's the decision behind what to cache and what not to cache?
Yeah.
Basically, how expensive something is to generate. If something is really expensive because it requires multiple database calls or multiple calls to Redis and back, or is just simply computationally intensive, or if it's just something that we feel is fairly static and you really don't need to generate it over and over and over, that's what we do. In general, the pages themselves on Stack Overflow are not cached. Okay. A subset of them might be cached for anonymous users, but we will tend to cache maybe fragments of HTML. And like I said, specific IDs of questions that correspond to certain criteria, for search, etc.
Thank you.
Okay. Anyone else?
Thank you. You talked about level 1 and level 2 cache.
Can't hear you.
Okay. Do you hear me?
I can hardly hear you. Sorry.
Excuse me. You talked about two kind of cache, level 1 and level 2 cache.
Yeah, level 1 and level 2 cache, that's right.
Can you tell us which kind of cache for level 1 you're using? Memcache, Redis, something else?
Level 1 is just memory, RAM,
Okay.
just objects in memory.
Okay.
Level 2 is Redis. It's serialized into Redis and deserialized out of Redis. That's
Okay.
it.
Just another question. You
Yep.
said that your database is too much large in
Yes.
order to use, for example, a cloud system or something else. Did you ever think about sharding the database into different one?
So you're saying the database is too large. Have we ever considered sharding? It's a strategy, but we don't need to shard. The database is at the moment run on single % CPU usage. It's not needed. We would need a very compelling reason in order to shard it before that happens. And right now we're not there.
This session
If
before
hardware
go out
reaches a
and leave the
point
headphone
level
on
where
the
it
chairs.
gets
Thank you.
too expensive, then it probably will be something that would be considered. Thank you.